Hello everyone, I am Rajarajeshwari from SNS College of Technology in the Department of Artificial Intelligence and Machine Learning. So in my lecture video today we are going to see about what is probability distribution in machine learning. Here just we have to recall the previous class of probability theory, which has the random variables, events and process. So which has random variables, which means numerical mapping of outcomes, and events is specific subsets of sample space, and process is which transform raw data into probabilistic models for automated decision making. So the thing which has the learning objectives of probability distribution is the main goal is we have to master the mathematical basis of probability distributions, and which is for classifying distinguish between discrete and continuous types, and which is implementation is for apply Gaussian distribution of machine learning or normal distribution of machine learning future engineering. So this is the learning objective of probability distribution. And what is probability distribution is the first thing is modeling future behavior. The definition of probability distribution is a mathematical function that provides the probability of occurrence of different possible outcomes, and the role is to describes how values are distributed for specific random variables and futures. So the ML context is used to estimate the likelihood of data point belonging to a class. So this is the major modeling future behavior. And this is the explanation. This is the graphical representation of probability density functions, and the random variables and distributions are future representation, which is continuous, discrete and mapping. So discrete is the countable values, which has the example of number of clicks, words count, that are all comes under discrete. And continuous is infinite values within a range, which has the image pixel intensity, sensor temperature. And ML mapping is futures are treated as a random variables governed by specific distributions. So the above the are random variables which has discrete and continuous graphical representations. So continuous means it has a curve like structure, and discrete has an bar graph, which is like a bar graph. And mapping is for random variables which governed by specific distributions. So the next thing is types of probability distributions, which is the same thing as discrete, continuous and cumulative. So discrete is a probability mass function for specific points, and continuous is for probability density functions, and probability is the area under the curve for an interval, and cumulative is some integral of probabilities up to point x. So these are the probability of discrete and continuous and cumulative functions of machine learning process. And which is the next thing is mean and variance. The mean is for quantifying centrality and spread. So mean, variance and relevance. So mean is for expected value, that is center of data, and variance is for dispersion or spread from the mean, and relevance is high variance indicates high uncertainty in model predictions. So these are the mean and variance. So the below are the formula. The formulas are going to see in next lecture video. Thank you.